One Java map just cost me over 7 seconds. The scary part, this isn't a bug. It's a feature you are likely paying for without knowing it. And here's what makes this even more interesting. The algorithm never changed. Same dataset, same machine, same Java virtual machine, only one line changed. Yet one implementation needed over 7 seconds, while the others finished in under 2. So where did 6 extra seconds go? The profiler showed exactly where they disappeared. Into the Integer.compareTo. So why did they go there? Eventually, someone pays for it. Trust me, every extra CPU cycle ends up on somebody's Amazon Web Service bill. But wait, let's investigate. Most importantly, should you stop using it? Most Java developers know these three collections. But if I asked which one is actually the most expensive, most people would probably get it wrong. So let's stop guessing and profile them. This is the code for our dataset generation. I'm using a fixed seed of 42, so every collection receives exactly the same dataset. There is another detail hiding in this dataset, and it changes everything. We are intentionally creating duplicates. Later, you will see why that matters. Remember this line highlighted because it's going to explain almost everything we see later. I'm generating 10 million values, and because the range is only 1/10 of the data size, duplicates are guaranteed. HashMap is a collection most backend systems rely on: APIs, caches, session storage, and the promise is simple: fast lookups. But let's see if reality agrees. That's fast. But what's surprising isn't HashMap, it's what happens when we change one line. HashMap is our baseline, but the real surprise happens when we ask the map to remember its history. Now things become interesting. Linked HashMap is basically HashMap with a memory. It remembers in session order, but ordering is never free. Internally, linked HashMap keeps a running list of everything you add in the exact order you added it. Every insertion now has extra bookkeeping work. Every update has to maintain that history. So naturally, we should expect a cost. Notice something, we are paying extra, but not much. So if linked HashMap only got slightly slower, why did TreeMap completely explode? This is the moment that surprised me. TreeMap doesn't just store data, it organizes it continuously, every insertion, every lookup, every update. An organization has a cost. The profiler isn't showing a bug, it's showing the price of a feature. Now let's profile all three together. This is almost the exact comparison I showed in the hook. The numbers may vary slightly from run to run, but the story remains the same. One implementation is consuming dramatically more CPU. Now, let's find out why. But wait a second, and here is the catch. What if IntelliJ is lying? What if our profiler result is not enough to justify our claims? So let's verify this with the Java Microbenchmark Harness. I rerun the experiment using the Java Microbenchmark Harness, Java's official benchmarking framework. HashMap finished in just over a second. Linked HashMap paid a small cost to maintain its session order. And TreeMap needed almost 10 seconds. Same dataset, Same algorithm, same machine. The only thing that changed was the collection. So where did those extra 8 seconds go? Because we have duplicates, TreeMap is traversing each tree over and over just to find the same keys to update. Every put isn't just an insert, it's a search. And that changes everything. Now we can finally answer the question why they went there. TreeMap is constantly comparing keys and constantly maintaining sorted order. The profiler isn't showing a bug. The that feature many developers choose without considering the cost effect. And remember that line from the dataset, that's what created all those duplicates. And duplicates amplify the cost of TreeMap searches, which is exactly why CompareTo put dominates the profiler. Here is the mistake many developers make. They choose the collection with the most features instead of the collection they actually need. Every feature has a cost. Ordering has a cost. Sorting has a cost. And eventually someone pays for it. A few milliseconds doesn't sound expensive until it runs millions of times a day. The profiler measures time, but Amazon Web Service measures money. The best collection isn't the one with the most features, it's the one solving your problem with the lowest cost. CPU time is only half the story because performance isn't just about speed, it's also about memory. In the next video, we'll measure exactly how much memory these collections allocate. And the results surprised me even more than the CPU test because Amazon Web Service doesn't just charge for compute, it charges for memory too. Subscribe if you are interested in performance engineering and backend architecture.